Number 16, balance this equation. Dotted line down, coefficient lines, atom key, nickel, carbon, and oxygen. Number of nickels is 1, carbons is 4, oxygen 4, nickel 1, carbon 1, oxygen 1. Okay, my nickels are balanced, my carbons are not, so I'm going to put a 4 here. That changes this to a 4 and this to a 4, and we're balanced. So the answers, the coefficients are 1, 1, 4. 17, balance this one. Dotted line down. Purpose for that is to separate the reactants and products. Purpose for these coefficient lines is to separate, to show you where you can put coefficients. Don't think that you can put a coefficient here. You're not allowed to do that because you can only add full molecules in these reactions. Just remember the rearranging atoms lab. Okay, looking good. My carbons are not balanced here, so I'm going to put 4 carbons. That changes the carbon to 4 and the oxygen to 8, which changes this oxygen to 9. Now, my hydrogens, I've got 10 over here and 2, so I'm going to put a 5 to change this to 10. 5 times 1 is 5. 5 plus 8 is now 13. Okay, now my carbons are balanced, my hydrogens are balanced. Here's the dilemma. There are 2 oxygens here. There's nothing I can multiply by 2, no whole number that I can multiply by 2 to get 13 oxygens. And so my problem is that this is an odd number. And I can see that this is an odd number because this is an odd number. So I need to make this an even number. So I'm going to get rid of this 5 and change it to a 10. So see, by doing that now I have 20 oxygens and I have 20 hydrogens and 10 oxygens, which changed this total to 18. Well, now my hydrogens is off. Hydrogens are off. I have 20 in the products and 10 in the reactants. So I'm going to change this to a 2, which makes the carbons 8 and the hydrogens 20. Hydrogens are balanced now. I need to go to my carbons, put an 8 here, which will change this to 8 and this to 16. 16 plus 10 is now 26 total. Whew, it's complicated here. 8, 20, good, good. Now I just need 26 oxygens. So 13 times 2 would be 26. Folks, that was quite fast, but it ended up working out. So if you need, feel free to pause the video, go back, try it yourself. Look how much I crossed out here. You can really see why it's important to do these balancing reactions neatly. Number 18, what are the 5 types of chemical reactions? Make a drawing or diagram to represent each. Well, okay. You've got synthesis, decomposition. I'm going to abbreviate that decomp. You've got single replacement. Oops. You've got a double replacement. And combustion. Synthesis, good drawing would be this. Fill in this one. Synthesis, remember, is just a combination reaction. So 2 atoms or 2 elements come together to make a compound, or 2 compounds come together to make a big compound. A decomposition reaction is basically the opposite. So you start with a compound and it breaks up into its elements. That's a decomp. Notice 2 element reactants here, 2 element products here. Single replacement. Yep, this is the one that represents the dance floor. I like this one. I'm going to change this to a square and an open circle. Okay. In a single replacement, this atom is going to bump out or replace this atom here. So now these two atoms are together, and you're left with your single guy, single element, square there. Double replacements, like the man with the hats, they switch hats. So I'll show this like this, and this. So notice in this one we've got two compounds. In single replacement we had an element plus a compound. So here, this is going to switch and now bond with the filled in white square, and the open square will be with the open circle. I like to think of this as A, B plus C, D. And so now A is with D and C is with B. And the last one's combustion. A drawing for that, you can just draw a big explosion, right? Because these are the really fun explosions. That's my horrible drawing of an explosion there. Really though, it's something with carbon, hydrogen, the subscripts do not matter. Sometimes it has oxygen in it. Always plus O2, and it always makes carbon dioxide and water. Always. So these three parts are always the same for a combustion reaction. Number 19, which type of reaction is each? Well, I just look at the reactants. That's an element, that's a compound, so this is probably going to be a single replacement. Let's just confirm. This one bumps out the iron, and look, lead is now with nitrate, and iron's left alone. So yes, this is single replacement. This is element and element. I'm going to guess this is synthesis, and sure enough, it makes only one product, so this is synthesis. And this one, compound, compound, this should be a small 3 there. But two compounds, that's going to be a double replacement. Double replacement. And look, you can see this iron was with the chlorine. Well, now over here is with the phosphate. And this ammonium was with the phosphate. Well, now it's with the chloride. So yeah, double switcheroo there. Number 20, what is the result of a combustion reaction? What is always the result? By result, it means products. It's always going to be carbon dioxide and water. Always. Number 21, write the chemical equation for potassium plus aluminum nitrate. Okay, well, potassium symbol is K, plus aluminum nitrate is AlNO3. Let's polish that up a little bit. Aluminum has I'll do some scratch work down here. Aluminum's got a +3, nitrate has a -1, so I need another nitrate and yet another nitrate. So this really becomes AlNO3, 3 aluminum nitrate. Now this is an element, that's a compound, so this is going to be a single replacement. Potassium is now going to be with nitrate, and aluminum is going to be displaced. So let's polish this up now. Potassium nitrate, potassium's a +1, nitrate's a -1, so that's good. Aluminum is not a diatomic, so we're good here. 22, write the chemical equation for calcium nitrate plus aluminum hydroxide. Okay, we need to polish up our reactants here. Calcium's a +2, nitrate is a -1, so I need another nitrate to balance out the charges. Aluminum's a +3, hydroxide is a -1, so I need 3 hydroxides to make the charge 0. Two compounds means that this is going to be a double replacement, so calcium will now be with hydroxide. And aluminum will now be with nitrates. Let's polish these up. Calcium's a +2, hydroxide's a -1, which means we need 2 hydroxides. Aluminum's a +3, nitrate's a -1, which means we need 3 nitrates.